This is a video that I've been threatening to make for a while now, and I think it's one that covers a subject which is often misunderstood. It's often not covered properly by people who do talk about this stuff. It's often misinterpreted, whatever word you want to use. But what we're going to do is we're going to talk about the main side wiring of your guitar amplifier. Specifically, the legal requirements for an amplifier sold in the UK market as of today. Now, I'm picking today because there are different rules for amplifiers sold in the past, and of course there will be different rules for amplifiers sold in the future as and when legislation invariably changes. So currently, if you are a manufacturer of an electrical appliance, electrical goods, electrical equipment, as the government calls it, and that doesn't matter whether you sell 1,000 units a year, 1,000,000 units a year, 10 units a year, or 1 unit a year. If you are building and selling an electrical appliance to a customer on a commercial basis, these rules apply to you. There's no workaround. There's no, yeah, but what if I do this or that? There's no, yeah, well, I'm not really doing it as a business, but, I'm just covering my costs, for the cost of the parts. It doesn't matter. The Office for Product Safety Standards do not care what your business setup is. If you have built an amplifier and sold it to someone for money as a new product, these rules apply to you. It's as black and white and as simple as that. Okay, so we are currently covered, and what we're talking about here is the electrical equipment in brackets safety regulations 2016 for Great Britain. And these regulations are what we call a living document, so they can be updated and the guidance can be updated at any time. And currently the latest update was March 2025. So only just a couple of months ago, these regulations and this guidance was updated. So that's where we're working to. Prior to the Electrical Equipment Safety Regulations 2016 for Great Britain, were the Electrical Equipment Safety Regulations 1994 Great Britain. Now those regulations were revoked on the 8th of December 2016, but continue to apply for products placed on the market prior to that date. And this is what I mentioned earlier, in that it matters when the product was manufactured and placed onto the market as to which regulations apply. So an amplifier built in 2015 will be covered by the old regulations. An amplifier placed on the market in 2017 will be covered by the new regulations. Okay? The regulations are slightly different for those who are pretty clued up on this stuff. Obviously, those dates line up with a certain withdrawal from the European market that the UK went through, and that guidance and those regulations have continued to evolve since then. Hence my talking about the living document thing. So that's what we're talking about today. Those are the rules and regs. And I'm going to explain it to you in the most simple and basic form that I can, so you can understand what are the basic requirements for main safety. We're not talking about anything, we're not talking about tubes, we're not talking about circuit boards, we're not talking about grounding schemes for the audio path. None of that. We're just talking about the mains wiring and what are the requirements. Hopefully what you will be able to do after this video, after watching this video, is to look at a piece of gear in a shop or on your repair bench, or a piece of gear that you've just bought. You could have a quick look inside and say, yeah, that complies, that's good. Or you could look at that piece of equipment and say, oh, hold on a minute, that's not quite right. I know that it should be like this. What's going on there? Now, there will be some amp builders watching this who, and you know who you are, will look at this and think, well, if I'm not doing what I should be doing, I know that. And if I copy what you're doing, Chris, and what you showed me today, will my amps now be legal? No, no. By doing this, you're ensuring that that part of your amplifier is legal. I'm not saying it's illegal. All right, there are other things as well further down the line that you also need to do to ensure your amplifier is fully legal, is safe, complies with all the regulations. But by doing this, you're at least ensuring that that part of your amplifier and that part of your circuit, that part of your electrical equipment does comply. Now, I also want to caveat this by saying these are the minimum, these are the absolute minimum basics that you should be doing. There are higher international standards to which you may choose to build your amplifiers to, and I highly recommend that you do so. I'll also say that this is only for amplifiers placed on the UK market. If you build an amplifier for a customer, let's say you're an American amp builder, and you have an order from a customer over here in the UK, you need to build that amplifier to the UK regs, not American regs. It is to where the amplifier is sold or to be used, the market in which it is placed, not the market in which it was manufactured. Okay. If your next customer after that lives in Australia, well, that amplifier needs to comply with all the regulations for Australian electrical equipment. If the amplifier after that is to be sold to Germany, well, then it needs to comply with EU regulations. Okay, and this is where a lot of the small boutique builders stumble, in that they don't understand that. Okay, the market in which you place that amplifier, i.e. where your customer is located, is the regs that you need to build the amplifier to. So there's really 2 or 3 things that we need to cover with our mains wiring. 1 is safety earthing, 2 is disconnect devices, and 3 is strain reliefs. Okay, if we get those 3 things right and we understand what's going on, you should be okay. So from the very beginning, obviously we need to get mains electricity into our chassis to power it up. And the regulations allow for 2 different methods of that. You can either use what we call an IEC socket cable, C14 female plug and a C13 socket on the chassis itself. You've seen how they work. Now, these can either be a single unit like this, or they can have a built-in fuse. Even better, or further than that, they could have a fuse and an on-off switch as well, so you could use an entire unit like that. That's one option, an IEC cable. The other option is a hardwired cable, like this, as you'd often see on tweed amps, like that Lazy J that came in, where the cable is hardwired to the amplifier, and because it's hardwired, there are a different set of requirements over using this. Whichever one you use, the same principles apply. Okay, and I'm going to draw it out for you. Guitar amplifiers, well, most of them, they should be, are what we call single phase appliances. So they use single phase electricity, they're not 3-phase. Nor, I mean, I don't know of any, but none of them are supplied by DC mains. Some amplifiers can have an internal battery supply, like those portable units. So again, they're covered by a different set of regulations, but we're talking about single phase AC mains, all right? So it's really quite simple, all right? If you use, well, the regulations require, as we know, so we've got the live coming in here, live, and we've got the neutral coming in here, neutral. The regulations require And this is a must. You must do this. No questions asked. You must allow for both the live and the neutral to be broken or disconnected at the same time. And that's covered under something called your disconnect device. Okay. And the reasons behind that is that in the event of a fault, whether that be a fault current flowing or fire or something along those lines, they want both the live and the neutral to be physically disconnected from the amplifier itself. Okay, and that disconnect must happen at exactly the same time. All right. There are two ways of doing this, two methods. One is a switch. It's easy enough. We've all seen double pole switches. Here's your switch. We've actually got two switches here. Got one on this side and one on this side with a single toggle, and that switch does both switches at the same time. So you can have the live coming into one side, the neutral coming into the other, and then you'll have your outputs on that side. Okay, does that make sense? So that switch makes or breaks that connection at the same time. So that could be your disconnect device, and that's a common way of doing it. If it is your disconnect device, it needs to be labelled on and off, both on the switch and also on the control panel as well, so the user knows which is which. All right. Your other method too is with a detachable mains cable, which is what this is. Okay, so we can physically, do you remember, the intention is to physically disconnect both the live and the neutral from the appliance at the same time. Well, it's plugged in, it's working, a fault happens, the user can now come in, disconnect that, and the amplifier is now isolated, disconnected from the main supply. All right, so you can choose whichever way you want to do it. It's quite simple, it's quite easy. So that's your two methods. Let's talk about the switch method first. So with the switch method, that means we've got a hardwired cable. So our cable's coming in now into the amplifier. So here's our chassis, and that comes in, and that's hardwired. Now, first of all, the regs say if you have a hardwired mains cable, you need two forms of strain relief. Okay, one on the chassis itself, and the regulations do state the standards and strength and the specifications of that strain relief. Really important. But they also want an external one, and that could just be simply a P-clip to the side of the cabinet. That's one way of doing things. All right. So, and then here's your plug, 1, 2, 3 prong. All right, so your hardwired mains cable comes in. You've got a strain relief here, external to the chassis, and you've got one internal to the chassis. That could be a strain relief in the hole there, or it could be another one mounted internally. All right. From there, your live must go to a fuse. Okay, your live, without exception, must go straight to a fuse. Okay, and again, the regulations surrounding what the fuse holders look like, how they work, etc., etc. Can I find one to show you? Yeah, here we go. So here's a fuse holder. Zoom you in. So this is a typical panel-mounted fuse holder. You see it's got two terminals. Now the live must go to this end terminal here. All right. So your live is going to come in and it's going to go to this end terminal here. Why? Because this side terminal, if the user pulls the fuse out, it means that the live disconnects first. All right, and when the end of the fuse touches this terminal as it comes out, you're not going to get a shock. This terminal then, the one on the side, okay, then goes on to your switch. You got that? Can you read what that says? Shall I just write that again? Switch. Okay, so your live comes in, 2 forms of strain relief, to the end of the fuse. From the side terminal onwards to your switch, and from there it will go onwards to the power transformer. Now, do you remember how I said the regulations require us to switch both the live and the neutral? Well, if our disconnect device is the switch needs to do both the live and the neutral. So it's going to be one of these types. Okay. So also coming in here is the neutral, which also goes to our switch. So you can draw it like that to say it's the same switch. Onwards to the power transformer, often the common. And in the UK, that will be the live will go to the 240 or 230 volt tap, whatever it's got. Okay, so that's the live and the neutral covered. So to recap, the live comes in to the fuse holder, onwards to our switch, onwards to the power transformer. The neutral comes in directly to the switch, so it's switched at the same time, onwards to the power transformer. That's the easy bit. The third wire, of course, is the earth, which is this green with yellow stripe, or yellow with green stripe, whichever way you want to look at it. I think they call it a green with yellow stripe. The regs around these for hardwired cables are really interesting. Okay, first of all, this needs to go to a dedicated point on the chassis. Okay, and that's often dictated by this symbol here. You may have seen it. This here must be dedicated to just this wire. It cannot serve any other purpose. You can't have any other wires going to it. You can't have anything else mounted to it. Okay, so that couldn't be, as is commonly seen, a transformer mounting bolt, because that's other purpose then would be to mount the transformer. It cannot be a piece of tag strip, as we saw in that Lazy J, as we've seen in other manufacturers as well, in fact. It's got to be a dedicated point just for this wire. Okay, and it's not difficult to look up the regulations of what the requirements are for how that grounding point, or earthing point, I should say, must be done. Okay, so you can look that up. That point must also be marked with that symbol. Now, there are various different ways to do that. Myself, I have this sticker sheet, and the size and detail of the marking is prescribed. It's all dictated. So I think it's an 11mm diameter circle. I use stickers. Some manufacturers, I remember Marshall and a lot of the solid state stuff, actually stamp the chassis. So that's the way they chose to do that. But it's a clearly marked point on the chassis dedicated for your safety earth. Now, I say this to everyone all the time. This pier, the way that this wire connects to the chassis, is the most important connection in your amplifier. Right? Nothing else matters. Because as long as this is good, you are safe. Right. Cool? Almost, a little bit more. If you have a hardwired mains cable and somebody comes along, a small child, a singer in your band, a drunken guy at the pub, you know, you're playing your gig, and he trips on this cable, we do not want this to come out. Okay, the whole point of this is hardwired and this is fixed. Okay, and this is why we've got these strain reliefs. So the strength of the strain reliefs again is prescribed, so you have to look up the regulations to what they need to be. Let's say somebody trips on your mains cable. You've got one level of protection here, so first of all this point would have to fail, then this point, okay, before there's a chance of this wire being ripped from the chassis. If it gets to that point, you know, the tug is strong enough that both of the strain reliefs fail, which they shouldn't, but if they do, we need to ensure that this earthing wire is the last one to be disconnected. Right, so that's connected there. And you do that by quite simply ensuring that this wire is longer than these two. Like that. Okay. So when that gets pulled out, the live and the neutral can become disconnected. And as long as your safety earth remains intact, was the last thing to become disconnected, you're fine. Okay, the user will be protected. All right, so if you look at, I'll put a screenshot on now of the Lazy J20 that I've just rebuilt. I've got a super long, it looks almost comical, safety earth wire in the chassis compared to the length of these two. So should the strain reliefs fail in the event of an accident, this is the last thing to become disconnected. It gives you the most level of protection. Okay. Other thing that the regulations require is that all of the live and the neutral connections, both to fuse holders and to switches. So on the live, for example, you can have one here, one here, one on the switch, and one on the output of the switch. So 1, 2, 3, 4. These must also be sheathed and protected. Easiest way to do that is with heat shrink. You can get boots and things. The regulations state what the minimum requirements are, and you can choose how you want to do that. But these should all be covered up. And as you see in the amplifier that I've just finished, that's what I've done. Same on the neutral. This one here and this one here also need to be protected. So you've got no open or exposed terminals right up until the power transformer. The earth wire does not need to be, but you can choose to if you want. Okay, so that's the switch side. So our disconnect device is the switch itself, switching both the live and the neutral at the same time. Upstream of the switch is the mains fuse for the amplifier. Of course, that needs to be adequately rated. All of your terminals are protected. You've got your safety earth bond here, the most important connection in the amplifier, has a dedicated point. Again, there are regulations surrounding that. Your earth wire is longer than your live and the neutral, and you've got 2 levels of strain relief. Okay. So when I open an amplifier that's got a hardwired mains cable, first thing I do is I look for that symbol. And if I can't see that symbol next to that point there, the amplifier is illegal. I then inspect that point. If it's got that sticker there, I inspect that point, and it should be doing nothing else other than being the bond point for this earth. If there's anything else on there, it's illegal. Then look at the live and the neutral, and I make sure that they're all shielded. I make sure the fuse is upstream of the switch, and I make sure that the live and the neutral are being switched at the same time. If it fails any of those tests, that amplifier is illegal and should not have been sold. It needs to be returned to the manufacturer for rectification. It's as simple as that. Okay. Also the strain reliefs, don't forget those. So it's not that difficult, it's not that complex, but you would be amazed at how many amplifier builders can't get this right. They just mess this up all the time, and it's so simple, it's so easy. All it takes is an hour of reading, understanding the regulations, what the requirements are, what your obligations are, and you get it right. Cool? Right, so that's the switch side. Let's look the other method to detachable. Detachable. Okay. So with a detachable mains cable, here's our chassis. Get that one out of the way. So now we're going to be looking at using an IEC socket with detachable three pin prong. You get the idea. So here's our mains plug. Here's our cable. And here's our IEC connector. Okay. Well, that's our disconnect device, right? And there'll be the male side is on the chassis itself. Okay. Well, that's your disconnect device, isn't it? Job done. Is it? No, the rest of the rules still apply. So your live comes in. Still needs to go to your fuse holder. Still needs to go to the end. Do you remember how I said it's got to go to the end, and then from the side terminal onwards to your switch. From your switch onwards to your 240 or 230 volt, whatever the transformer's got. Okay, that's your live. If I just put that here, you can kind of get an idea of how they differ. The neutral comes in. Now, because this, with a neutral, because the IEC socket itself is our disconnect device, we no longer need to switch the neutral, because the disconnect device is switching our live and neutral. So this could go directly to the common on the power transformer. All right, it could do that. Alternatively, you can choose to switch it anyway. Doesn't matter. All right, that's an alternative. So just like you did up here, if you want to switch both the live and the neutral internally at the chassis as well, you can do so, but you don't have to. So over this side, it needs to be a double pole single throw switch. Up here, all you need is a single pole single throw switch. So you just need to switch the live. You can do the neutral at the same time if you wish, but you do not have to. It's optional at this point. And it's up to you which way around you want to do that, because your IEC socket is the disconnect device. I haven't left enough room here. Your earth still needs to go to a dedicated earthing point here, somewhere on the chassis. All right. So that still, those rules still apply. A dedicated bonding point for your earth. Nothing else has changed there, apart from the length of that wire. It no longer needs to be longer than the live and the neutral inside the chassis, because there's very little risk of it being pulled out. Some builders still like to do a long earth wire from your IEC socket to your bonding point, just in case, for example, and it's very, very rare, the IEC socket itself, I don't know, it breaks off and it can get yanked out. Very, very rare for that to happen. The whole point of these is that they're quite easy to pull out, so this will always come out first. But, you know, how strong do you want to build them? That's up to you. But we're talking about the minimum requirements here. Okay, so that's the detachable side. And again, this point, this point, this point, and this point, and your neutral to your transformer, whether it's via a switch or not, they all need to be shielded terminals. So again, heat shrink is one way of doing it. You can get those big boots that do the whole thing. Whichever way round you choose to do it, as long as they are not open terminals, you are fine. So, does that make sense? You've got two ways, side by side, to do your mains wiring in an amplifier. You could say, I'm going to hardwire it, and therefore I need to follow these rules, or I'm going to have a detachable mains cable, and therefore I need to follow these rules. Now, as I said at the beginning, just by doing this does not make your amplifier legal. There are other things to do as well. There are other things in the regulations that you are required to do, but at least if you do this right, you've got the basics right and a good foundation to go from. So again, you can look into that. You can read into that, look into that, discover that, work out what's what and how you want to do it. But hopefully that makes sense. So now we could look at any amplifier. And in fact, should we do that? Should we look at an amplifier, see if we can work out what's going on? So here's that Marshall TSL. It's got an IEC socket on the back here, as you can see. Okay, the live and the neutral are part of the PCB board, so there's no way you can get to those. But our safety earth, look, goes to a dedicated point, and I don't know if you can see on the chassis there. There's your stamp. All right. Cool. Okay, so hopefully that all makes sense. Two ways of doing your mains wiring on an amplifier. So you guys should all want to know what to look out for, how things should be done, what we're looking for in terms of minimum standards, minimum requirements, minimum obligations to your customers. People often shout at me for saying this, but I'm going to say it because I think it's important. If you buy an amplifier and it does not comply with even the most basic safety regulations and requirements that it has to be built to, there's no, as I said, there's no grey area here. It must be built to those minimum safety requirements. If it doesn't, there can only ever be two reasons for that. One is that the builder does not know what the regulations are, and then you quite rightly could ask the question, well, why not? Why don't they know? Couldn't they be bothered to look it up? Did they not think, maybe I should probably check whether I'm doing this right? And now that scares me. Okay. The other reason is that they do know what the regulations are, and they've read them and thought, nah, I ain't doing that. Sod that. I'm just going to do it my way. That's even scarier, because that's showing that they really don't care about you. They don't care about burning your house down. They don't care about fatal injury. They don't care about any of that for whatever reason. Essentially, they're saying, F you and your safety. I don't care about that. Sod you. Both of those reasons scare me, and this is why I bang on about it all the time. Okay, so if we block diagram the amplifier, we'll call this the mains, we'll call this the preamp, we'll call this the power. So your rectifier, your whole voltage supply, etc. And here's your speaker. Realistically, really, honestly, I don't really care what you do in here. You could be the world's neatest builder in the preamp and the power amp of the amplifier. This is your speaker. I've drawn it separately because it might be in a separate enclosure to the amplifier chassis. You could be as neat as you want in here. You could be the most artistic builder in the world, super nice wire runs and lead dress and all that kind of stuff. But if you get this wrong, it doesn't matter. You've messed up. You could get this bit right and be messy and as untidy and poor layout and all that kind of stuff, and we most likely will come along and say, this isn't built to a particularly high standard, these things can be done better, but at least the amplifier will be safe. You have to get this bit right. Okay, Now, I strive for both, and you've seen that. I want my amplifiers to fully comply, not just with the minimum regulations, but higher standards as well. And the one that I generally aim for is IEC 62368-1, which replaced 60065. That's an international standard. And I aim to build my amplifiers to meet or exceed those standards. Sometimes it's not always possible. Sometimes there's a clash between what is a good recommendation and what the requirements are for a certain market in which you're selling. So again, you need to study and learn this stuff. But let's leave it at that. Hope that all that makes sense. As long as this is right, you're good to go. You can be messy here, but you can't be messy here. If you get this right, fine. If you get that wrong, shame on you. Cool, we got that. Thumbs up. Catch you at the next one.